Hello, everyone. This is a supplemental lecture for the lecture notes on beams. And this lecture is about beams and columns, but we will be focusing here on beams and how they shape space. I'll give an example in terms of the Ramon Magsaysay Center in Rojas Boulevard. This was designed by Alfredo Luz, and it was built in 1967. This building is a 18-story building, and it features a plaza and memorabilia for the past president Ramon Magsaysay, and an office tower building. Underneath the plaza is the parking area or the parking garage. Now, I want to focus on the tower and how the framing, the floor framing system contributes to the shaping of rental offices for the building. So the building is the typical floor plan is square, and the building is propped up by 12 columns, and they're spaced around 8 meters apart, and there is a cantilever all around, a 4-meter cantilever all around. In the middle is the core, where you have the 4 elevators and 2 fire escape stairs, an electrical room, and a storage area. And then the columns or support beams, and you can see here that the beams are all regularly spaced, such that they're 8 meters apart with that 4-meter cantilever around. Of course, do not mind this because this is a distortion already of the drawing that where this picture came from, but it should be a square. And of course, you will have that edge beam here. That edge beam is needed to add lateral support to the other beams. Also, the edge beam is needed to support the walls that it will be carrying on the facade. Now, how do I know that there are no columns here? I know it for a fact because my dad used to work in this building. In fact, his office would be here, around here. And I know that there is a column here along the wall here, and then there is a party wall here shared with another partner here. So I know that. And then I know that this facade, all the facades have no columns because you can see that there are no fat columns here. All the columns are set inside, and so all of these are cantilevered beams all around each floor. Now, the beauty of this is what you call an open plan, and the beauty of this open plan is that it allows the building owner to rent out the space such that it has a versatile layout. You can rent half the space, or you can rent the whole space for one office. You can rent quarter of the space, or you can even rent, an eighth of the spaces, like so, and then all of them have access to the elevator lobby. So this is a good example of an open plan. Of course, an office building is relatively much easier to design because you're not constrained by a very strict program. All your program that you have to follow is only the amount of rentable space that you have to provide. And so this is a good example of an open plan office building where you have a very versatile variety of options for rental spaces. Now, the beauty of open plans is that one, you can have a vast amount of space, and I want you to take note of the ceilings here, okay, or the lack of the ceiling, and then the beams here. you can see that there is a girder carrying the minor beams here. So that girder is carried by the column here. So in fact, this floor framing system that we see here is lends to the creation of open plan. Another example of an open plan is an office wherein you have a ceiling here, but now you have to pay attention to the columns. As you can see here, although the lecture should not be focusing on columns, but uh, discussing columns is inevitable when you discuss beams because the columns are supporting the beams. But you can already read how beams are being laid out in this floor. You know that there is a main beam running here, and then there will be uh, beams running also here, and then there might be minor beams in between this large span here. So open plans are good as long as you know how to uh, space your uh, beams and your beam supports, which are the columns. Now, as opposed to open plans, closed plans, on the other hand, uh, give you a very fixed manner of arranging spaces. However, you have when you're designing closed plans, such as this example here, it's a condominium building. Note that the dimensions of the condominium unit 6 by 9 is repeated in another unit here with a cantilevered portion here. Um, this allows if you make your uh, condominium module, or condominium unit a modular dimension like 6 by 9, and then it's also 6 by 9. It allows you more. One, it gives regularity to your structural framing, and two, it still allows you some flexibility in terms of designating spaces within that module of 6 by 9. So here you have an extension of the beams here, which are cantilevered, and then this part here is another part of the building, which starts another adjoining uh, condominium unit beside. The last example I want to show you is this classic example of modern architecture by Le Corbusier, Villiers-Savoy, wherein Le Corbusier employed the grid system, wherein you can see here that his grid is mostly squares. However, in the middle, he exercised some liberty in terms of relocating some of the beam supports such that they do not actually fall in line with the grid. However, you can see that even as he does not strictly follow his grid, in a way there is still some sense of regularity in the way he uh, uh, skews off the grid that he has established. So, for example, this is the ground floor here. So the ground floor is that this column here, or this load-bearing wall here, is aligned with this grid, or this grid line here, that one here. And then you can see that in some of the walls on the ground floor, they are aligned here on the second floor, and also here, somehow here on the third floor. Now, the second floor is broken by a ramp, and then the ramp is surrounded by a retaining wall or a shear wall here. So that shear wall is, in a way, breaks the grid, but yet it still follows some pattern or minor pattern of the grid, or a smaller version of the grid. So when you're designing buildings, it's a good practice also to keep in mind your structural components, such that if you can make them regular, having a regular pattern, then the pattern itself can lend it to an expression also in terms of your architecture, uh, as seen here with the Villa Savoy. The regular pattern of the columns here are help uh, uh, bring forth his ideas about regularity in industrialization of parts in building. So that's it. I hope you picked up some stuff that will supplement written lectures that I gave you earlier. That's it. Thank you.